Hi, we are looking at word problems using systems of equations, and we are actually in Unit 5. This is either the end of Day 2's notes, or it could be Day 3, depending on how your classes have gone this week. So when we have systems of equations, of course, we have two or more equations that have the same exact variables. We are using different methods to try to find a solution for our system. So that's still what we're doing, but in this case, we're just going to be solving problems that are given to us in word problem format. So these are practical applications. So what we're going to do is read the problem and then define the variables. What exactly are our variables? What are the things that could change? And then we're going to write out the system of equations. We have to write our own equations, which is possibly the most challenging part here. And then we have to solve the system. We can solve the system any which way we want to. Generally, we can solve the system using substitution or graphing or elimination. And then, of course, we want to make sure to check our solution with a word problem. Check your solution, not only by checking your ordered pairs in both equations, but also make sure that your answers make sense. Okay, so problem 1 here. We have a group of 40 children. They attended a baseball game on a field trip. Each child bought either a hot dog or a bag of popcorn. So every single hot dog was $2.25, and every single bag of popcorn was $1.75. Our total bill was $83.50. So we want to know how many hot dogs were ordered. So this is another thing to pay attention to. The question is how many hot dogs were ordered. It's not give me an ordered pair to describe this situation. All right, so I'm going to define my variables. I'm going to say X equals the number of hot dogs that were purchased. And I'm going to say Y equals the bags of popcorn that were purchased. And it is really helpful to at least write down a little note or use letters that make sense to you so that you know which variable you're talking about when. Okay, so we have 40 children who went to this baseball game. So the total number of items was 40, right? We had, between hot dogs and popcorn, 40 things were purchased. So I know X plus Y equals 40. That is my first equation. So every time you read a word problem, you're going to have to try to figure out what are the two equations that you can pull from here. Right, so I know 40 children attended, so that's where I used the 40. The other piece of information I have is the amount of money that was spent was $83.50, and hot dogs are $2.25, and popcorn is $1.75. So we're going to make an equation using that information, the money information. All right, so hot dogs are X, right? We defined X as hot dogs, and I know every single hot dog was $2.25. So I have $2.25 times the number of hot dogs we purchased, plus $1.75 times the number of bags of popcorn that we purchased. This is all the money stuff, and so it equals $83.50. Okay, so now I just have two equations, and I can solve using substitution or elimination or graphing. Okay, so I am going to use substitution because X plus Y equals 40 is pretty easy to change to substitution. So I'm just going to rewrite that. I'm going to rearrange it, and this is going to be Y equals negative X plus 40. Okay, I'm just rewriting that. And then I'm going to substitute that into my lower equation. So I know what Y is. So I'm going to rewrite 2.25x plus 1.75. Instead of Y, I'm going to plug in this information, right? This is also Y. So I'm going to just drop that in, times negative x plus 40, and it all equals 83.50. Okay, so I'm already starting to solve on this column here underneath, write the two equations. I'm starting to solve because I know I'm going to need lots of room. Okay, all right, so I'm just going to solve this. 2.25x minus 1.75x plus 70 equals 83.50, 83.50. Okay, so 2.25 minus 1.75 is 0.5x, and I'm going to say that equals 1350. I did two things in one there. I combined my like terms and then I subtracted 70 from each side. Okay, and now be careful here, right? I'm going to divide each side by 0.5, so that's actually going to effectively double 1350. So if I come up here, I'm still solving. When I'm solving for x, x equals 27. What does that mean? Well, remember I said x is hot dogs. That must mean that I purchased 27 hot dogs. And then if I plug 27 in, x plus y equals 40, then I know y equals 13. The question was how many hot dogs were ordered, so the answer is 27 hot dogs. Okay, when you check your work, don't just check in one equation. I know 27 plus 13 equals 40, so that means that there were 40 items purchased. I can also plug, if I got 27 hot dogs, I can plug that back in, and my 13 bags of popcorn, I can plug it back in and make sure it was the correct amount of money. And I just want to make sure it makes sense. I want to make sure I'm not, purchasing a negative number of hot dogs or something. That can happen sometimes with our word problems, but usually they're going to be more logical than that. Okay, so we're going to move on here. Giselle works as a carpenter and as a blacksmith. So she earns $20 an hour if she's working as a carpenter. She earns $25 an hour if she's working as a blacksmith. So it depends on which skill she's using. Last week, Giselle worked both jobs for a combined total of 30 hours. And she earned a grand total of $690. So we want to know how many hours of those hours that she worked, how many hours did she work directly as a carpenter? All right, so she works as a carpenter and as a blacksmith. So what I'm going to do is I'm going to say X is her carpenter's hours. And I'm going to say Y is her blacksmith hours. Okay, so I've just defined my X's and my Y's. So I know that last week she worked for a total of 30 hours. Right? So if she worked as a carpenter and as a blacksmith, she worked for X plus Y equals 30 hours total. So what else do I know? I know some money information, right? I know some money information. So if she earns $20 an hour as a carpenter, 20 times X, right? $20 for every hour she works as a carpenter. She earns $25 every time she is being back at her blacksmith. So she's going to be 25 times Y, because Y is blacksmith, and she earned $690. So you can see now that we have our two equations, and so now we're going to go ahead and start to solve. Again, we can solve by substitution or elimination or by graphing. Substitution would be pretty easy here. So I'm going to say that Y equals negative X plus 30. And I had done that in a different color earlier, just to show it's the same exact equation. Y equals negative X plus 30. I shouldn't say that. It's not the same. It's an equivalent bit of information. It's not the exact equation. Okay, I'm going to start to solve. And again, I'm going to start to solve in this column where I've written those two equations. So I'm going to be using substitution, not elimination, but you can use whichever one you like better. I'm going to plug this information in for Y. So I have 20x plus 25 times negative x plus 30 equals 690. And if I continue to work on that, I'm going to get 20x minus 25x plus 750. Yes. And this all equals 690 because that's the amount of work. Money that she made. 20x minus 25x, I have negative 5x. I'm going to subtract 750 from each side, so I have negative 60, and that means that x equals 12. What does that mean to me? Well, I said x is the number of hours she worked as a carpenter. This has only asked me that. How many hours did she work as a carpenter? She worked 12 hours as a carpenter. Okay, but because I want to just be sure that I didn't make a careless error somewhere, I am going to plug back in my information. If she worked 12 hours as a carpenter, then she worked 18 hours as a blacksmith, right? Because 12 plus 18 equals 30. And I can plug the number of hours she worked as a carpenter in. She gets $20 an hour per carpenter. and she gets $25 an hour per blacksmith hour. And so if you plug your information back in, 12 hours as a carpenter, 18 hours as a blacksmith, then you're going to get that correct amount of money. So just double check, make sure it seems logical. All right. Number 3, you've gone to a fruit stand for fresh produce. And you can try this and pause the video and then come back and see if you've set up your variables in the same way, or even work the whole problem and see if you get the right answer. You've gone to a fruit stand for fresh produce. The person in front of you gets 5 apples and 4 oranges for $10. You get 5 apples and 5 oranges for $11. So how much is the price of an apple and an orange? In this case, we want to know the price of each item, so we do need to solve for everything. All right, so I need to define my variables. I'm going to say x equals apples, and I'm going to say y equals oranges. Right? I know that the person before me got 5 apples and 4 oranges, so 5 x's, right? Plus 4 oranges. And I know that that person spent $10. I went and I got 5 apples and 5 oranges, and I spent $11. So I'm going to solve. Now, in this case, I'm probably not going to use substitution, although you could. That is up to you. But in this case, I'm probably not going to use substitution. So what I'm going to do is subtract this whole second equation from the top equation. Okay, so 5x minus 5x is 0. 4y minus 5y is negative 1y. 10 minus 11 is negative 1. If negative y equals negative 1, then y equals positive 1. What that means to me is that how much money am I spending? Remember, this is dollars over here. I have $1 for every orange. Then I need to figure out how much money an apple costs. So I'm going to go back to an original equation always, not to something that I have simplified. So I'm going to go back to this original equation, 5x plus 4y equals 10. If y is 1, then I know 5x plus 4 equals 10. 5x equals 10 minus 4, which is 6. X equals 6 fifths, excuse me, and we don't do money in fractions, right? So if I figure out that amount, it's 1.2 or 1.20. Okay, so I know that if every single orange I purchase is $1, then every single apple I purchase is $1.20. And I can go back and make sure that makes sense. So the person before me got 5 apples, so 5 times $1 is 5 times $1.20 is $6, right? And the person in front of me got 4 oranges, so I had $6 in apples and $4 in oranges, right? And then when I do my own math, I have $6 in apples and $5 in oranges. Okay, so if X is apples, I'm going to say $1.20 per apple. Let's pretend I wrote that in the normal spot, and we're going to say $1 per orange. Okay, so more of these problems. And again, try these on your own and come back and check to see if you've set it up the right way, or check to see if you got the answer correct. Peg has $5.50 in dimes and quarters. She has 8 more quarters than dimes. We want to know how many quarters does she have. So I'm going to warn you, when you're working with money like this, where you're talking about coins and you're talking about dollars, be careful, because you know a dime is worth 10 cents, which is $0.1, right? So I normally just make my dollars when I'm working with a problem like this where I have coins. I will just change $5.50 over here into 550 cents. I'll just change it, 550 cents, because you know $5.50 equals 550 cents, and that way I'm not having to worry about my decimals. All right, so Peg has $5.50 in dimes and quarters, and she has 8 more quarters than dimes. So let's go ahead and define our variables. This time I'm going to be very exciting, and I'm going to say D equals dimes instead of X or Y. Okay, doesn't really matter. That's why I'm defining them over here. Q is quarters. So I have two pieces of information. I know we have 550 cents, and I know that dimes are worth 10 cents, right? So 10 cents times every dime plus 25 cents times every quarter that she has a total of 550 cents. I also know that she has 8 more quarters than dimes. So whatever number of dimes she has, if you add 8 to the number of dimes she has, then you figure out how many quarters she has. Okay, so now I'm probably just going to use substitution because I'm already set up. I know what Q is. Q is D plus 8. So as I start to solve this, I'm going to say 10D plus 25. Instead of Q, I'm plugging all of this information in, and it all equals 550. So 10D plus 25D plus 200 equals 550. And I'm continuing to solve up here. And so I have 35D. Excuse me. What's that? I'm saying the right things, but I'm not writing the correct things. I have 35. 10 plus 25 is 35. 35D, 35 dimes, equals 350, because I subtracted 200 from each side. And so D equals 10. I have 10 dimes. All right, if I have 10 dimes, I have 8 more quarters than dimes, so I must have 18 quarters, right? Quarters equals 18. How many quarters does she have? That's the question. She has 18 quarters. That is my answer. So be careful, make sure you're answering the question that is being asked. All right. The length of a rectangle is 1 centimeter less than twice its width. What does that mean? If I have some sort of a rectangle that looks like that guy, that's my cursive LW. The length is 1 centimeter less than twice its width. The length is, right? Length is 1 centimeter less than twice its width. So I'm going to say twice its width minus 1. 1 centimeter less than twice the width. Okay, this is a 1. Careful with your 1s and your L's. All right, the perimeter is 40 centimeters. So remember, the perimeter of a rectangle or a square, you're just adding up all of the sides. So I normally would write this as either 2L plus 2W or 2W plus 2L. It is length plus width plus length plus width. So look at this. I have 2 pieces of information, right? Because I know the perimeter equals 40. They told me. So if the perimeter equals 40, then I know 2L plus 2W equals 40. So I have 2 equations with the same variables, and this one is very nicely set up for me to use substitution. So on my next equation, I'm going to say 2L, but I'm going to plug in or substitute what I know L equals. So 2 times, instead of L, I'm going to say 2W minus 1 plus 2W equals 40. That means 4W minus 2 plus 2W equals 40. Continue on. 4W plus 2W is 6W. I'm going to add 2 to each side now. 6W equals 42, and W equals 7. W is my width, and I didn't write those down. I could have written L equals length and W equals width. I guess I didn't because I drew that rectangle there. If my width is 7, then I know the length is 1 less than 2 times the width, right? So 2 times the width is 14, minus 1 is 13. So I know my length must equal 13. And I just want to kind of make sure that makes sense. And it seems like that could work out. I don't have any negative distances or anything like that. The perimeter is 40. Find the dimensions. So the dimensions, it wants to know what's the width, what's the length. Those are my dimensions, 7 and 13. Okay, I can double check and make sure that gives me the correct perimeter. So I can plug back in over here. I know the perimeter is 40, so 2 times the length, which is 13, that's 26. 26 plus 2 times the width, that's 14, really is 40. All right. Adult tickets to a play cost $5 and student tickets cost $2. So in all, 720 tickets were sold, and we have a total of $2,600 and $2,640. I'm going to say A is the number of adult tickets, and I'm going to say S is the number of student tickets. Right? So I know if there were a total of 720 tickets, then adult tickets plus student tickets has to equal 720 total tickets. The other information I have is all the money stuff. Okay, so I know that adult tickets were $5, $5 times every adult ticket plus $2 times every student ticket, and the amount of money we made was $2,640. So here I have my two equations. And so I can set this up to be elimination or substitution. This time, just for fun, I'm going to actually do elimination. So I can choose either my A or my S. I'm going to choose my A just because it's first. Maybe I should have chosen the S because it's a smaller coefficient that I have to match, but I'm going to do this. I'm going to multiply this whole thing times -5, the whole upper equation. Okay, and so what I end up with is -5A minus 5S equals -3,600. Okay, I just multiplied -5 times every term in that upper equation. And I'm going to bring down the lower equation and just have them all nicely lined up. Okay, and then I'm going to add them together because the way I defined, or the way I manipulated my first equation, I did it in a way that I can just add these two together. So -5A and +5A, poof, they're gone. -5S and 2S is -3S, and that all equals -960. -960. Okay, I'm continuing on. So I know that S equals 320. What does that mean? It means we sold 320 student tickets. If I sold 320 student tickets, that means I sold 400 adult tickets. And the question was, how many student tickets were sold? 320 student tickets is the answer, because that was the question, how many student tickets? Okay, we're almost done. Jim wants to buy a 5-pound mixture of chocolates. If kind 1 sells for $1.80 a pound and kind 2 sells for $2.30 a pound, how much of each kind of chocolate can he buy if he wants to spend $10? I need to define my variable, so I'm going to say that X equals the number of pounds of kind 1. So pounds of chocolate kind 1. And I'm going to say Y is the number of pounds he buys of chocolate kind 2. Maybe he's buying dark chocolate and milk chocolate, who knows. Okay, so I know that he wants to buy a 5-pound mixture, right? So the number of pounds he's going to get is 5. So kind 1 pounds plus kind 2 pounds has to equal 5 pounds. I also know the money information, right? So kind 1 is $1.80 a pound. So 1.80 times X, because kind 1 is X. And then I know kind 2 is $2.30 a pound. So we're going to say for every pound of kind 2, it's $2.30. And I know that that's going to be a total of $10. That's what he's allowed to spend, right? So this guy probably makes sense to do as substitution. I'm going to substitute, I'm going to isolate the X, but it is up to you which one you isolate. So if you choose to substitute for Y, that's okay. Your answer should be the same. Your numbers will just look a tiny bit different from mine. All right, so X is 5 minus Y, so I'm going to say 1.80 times, instead of X, I'm just going to plug in 5 minus Y, plus 2 let's make that 2.30. Double check and make sure that you have written $2.30. I wrote the wrong thing. 2.30 Y equals 10. I'm just substituting here and solving, so I'm going to end up with 9 minus 1.8y plus 2.3y equals 10. Forgive me, I dropped my extra 0 that I don't really need until I'm talking about the money answer in the end. This means that 9 minus 0.5y equals 10. So negative 0.5y equals 1. And y, that's lies. 10, 9, sorry, that's plus. Negative 1.8y and 2.3y, it's really positive, right? Because 2.3 is bigger than negative, 2.3 is bigger than 1.8. 9 plus 0.5y equals 10, which means 0.5y equals 10. So I am dividing by 0.5 or dividing by 1/2, and that means that y equals 2. Okay, 2 pounds of the second type of chocolate. And if I'm getting a total of 5 pounds, that means X has to be 3 pounds, right? So I'm going to get 3 pounds of kind 1, and I'm going to get 2 pounds of kind 2, and I can plug that information back in to make sure that I am spending exactly $10. Okay, the question said, how much of each kind can he buy? So 2 pounds kind 1 and 3 pounds kind 2. Finally, this is our last question. The length of a rectangle exceeds its width by 3 meters. We have another rectangle. The length exceeds the width by 3 meters. Okay, so I know that the length is bigger than the width by 3 meters. Make sense? It also tells me the perimeter is 58 meters. So remember, perimeter is 2 times the length plus 2 times the width. And they are telling me that the perimeter is 58. Right, perimeter is 58. So I'm going to combine these two things, right? I'm going to say that 58 equals 2 times the length plus 2 times the width. All right, and so I'm just going to use substitution because that's already got the length all isolated for me. So I have 58 times, that's not what I have. Long video, obviously tripping over my own words. Let's say we have 58 equals, that looks better, 2 times, instead of length, I'm going to put in my substitution right there, plus 2w. Okay, and so I have 58 equals 2w plus 6 plus 2w. So 58 equals 4w plus 6. I will come right on up here and I will say that 52 equals 4w, which means that 13 equals w. The width is 13. We said that the length of the rectangle exceeds the width by 3 meters. So if the width is 13, the length must be 3 meters more than that. So I'm going to say 16 is my length. What did it ask me for? It asked me for the dimensions. 13 is my width, 16 is my length. All right, thanks so much for watching, and stay tuned for more information on solving systems of equations.